everyone, and welcome back to another video provided by SVSU's online tutoring. My name is Joel, and today we'll be finishing up with section 9.1, exponential functions, with some applications. And the first application example that we'll go over is radioactive decay. And I just wanted to get this out of the way real quick because the other two examples deal with interest rates and thing completely unrelated to radioactive decay. So suppose, for instance, that we have some element that has a half-life of 10 years. So element has half-life of 10 years. And the initial mass is 10, or not 10, but let's not do 10, let's do 15 grams. And so we want to know how much of the mass is left, how much of the mass is left after 53 years. So what we have to do is that we have to set up an equation. And so the equation that we'll be using is we have y, which is our final mass, equal to 15, which is our initial mass that we start with. And since we're taking the half-life, we multiply it by 1/2 raised to t, which is the amount of time in years, divided by 10, which is the half-life time. And so this is our mathematical expression for our radioactive isotope. So all we have to do here is just plug in the time here, right, which is the 53 for t. So we have y equal to 15 times 1/2 raised to the 53 divided by 10. And you could simplify that by saying 15 divided by 1/2 raised to the 5.3. And so if we go to our calculator and calculate that real quick, we end up with a remaining mass of 0.3807 grams after 53 years. And so the takeaway from this is that if you were to sketch this graph of this function, you would notice that it follows this type of pattern. Of course, not drawn to scale. Actually, I'll just get rid of that last stick mark so that way it looks better. So at 0 years, we have 15 grams, okay? And so let me go ahead and draw the years there. So at 0 years, all the mass is there, right? But after a decade, we end up with half of our mass left. So that's 7.5 right there. And after another decade, we have another half of our radioactive isotope. And after another decade, right, we have half of our remaining mass. So as you can see, if we were to sketch this, it begins to follow an exponential decay. Except for that last bit there, because my pen slipped. Yeah, just like that. So, yeah, because the half-life is 10 years, for every 10 years that pass, half of the mass will decay. And so we can expect that after 53 years, or after 50 years and then some, we should have, you know, around this much mass. And so this number right here, if you were to approximate, isn't too far off from what we actually get. So that's the main takeaway there. When you're dealing with half-lives, you're every time a cycle of the half-life passes, you lose half of your mass each time. Okay, see you next time.